Alright, so I believe this is recording. Let's take a look at this homework 9 problems. It wants us to enter an equation for a polynomial function that has zeros at -4, so in factored form we'll write that as x plus 4. At -1 in factored form is x plus 1, and at x equals 2 is x minus 2. We can pick any number that we'd want out here as a leading coefficient. I'm just going to pick 1, and we could pick any multiplicities that we want. So I'm just going to pick minimum degrees. I'm going to leave my answer in factored form, so that's it for problem number 1. Let's move on to problem number 2. Now, here in factored form, that's x plus 2. Here this is just x minus 0, which is just going to be x. Now the 2/3. They do want us to recognize that if x were equal to 2/3, let's go backwards. Let's multiply both sides. We're solving this to get a 0 on the right hand side. Multiply both sides by 3, subtract 2, and we have 3x minus 2 is equal to 0. That's how they're expecting us to write, when you have a fraction, to write it as 3x minus 2. Okay, the denominator is always going to be the coefficient in front of x, and the other number there is going to, the numerator is going to be the opposite here. X equals 4 is written as x minus 4. We can pick any leading coefficient that we want. I'm just going to pick -1, and we can have any exponents on there we want, and I'm just going to leave them all as 1. So there's my answer for number 2, and you don't even need to technically really write a 1 right there, it's implied. But I'm just saying that if you wanted to pick a -2 or a -1/2, it'd be the correct answer. Now, most people are probably going to write x minus 0 as x, so actually let's write this as, and put that factor first, x times x plus 2 times 3x minus 2 times x minus 4. If it were a multiple choice test, you might have to manipulate your answer and write it by exchanging the order of the factors. But there's my answer for number 2. Okay, so here the directions change. It wants us to find the y-intercept, the x-intercepts, and it wants us to give further information about the x-intercepts to determine if it crosses, or when they say, it should say crosses or does a touch and turn. Alright, so to find the y-intercept, I don't have that. I'm going to pause this. Alright, so I'm back. I hope this seems to be recording. Let's find the y-intercept by letting x equal 0. As soon as you see that factor of x, it doesn't matter the stuff that follows it, the 0, minus 1, all that, because you're multiplying by 0. So we know that the y-intercept is 0, that this graph is passing through the origin. So I know that in my list of x-intercepts, 0 is also going to appear as an x-intercept. Let's set the output of this function equal to 0, and let's factor this. X cubed, x minus 1 squared, 3x minus 4. So they factored it for us. And this time I'm going to present my x-intercepts that are also called the zeros of the function in a table. And I'm going to include something that we call the multiplicity, and use that multiplicity to tell you whether the graph crosses the x-axis at that 0, at that x-intercept, or if it does a touch and turn, and I'm just going to abbreviate touch and turn as TNT. So x equals 0, if that's true, that whole thing is 0. That was to be expected because y was 0. 1 minus 1 gives me a 0, and this is a two-step equation. To solve for it, add 4 and divide by 3. So I get 4/3. This exponent here, this multiplicity is 3. For x minus 1, this exponent multiplicity is 2, and a 1 is implied right there, and that's 1. If the multiplicity is odd, then at x equals 0, it is crossing through the x-axis. If the multiplicity is an even number like 2, it does a touch and turn, and I'm abbreviating touch and turn with TNT. If x equals 4/3, the multiplicity here is 1, so at x equals 4/3, the graph is crossing the x-axis. So that's what it wanted for number 3. Let's move on now to number 4. To find the y-intercept, we let x equal 0, and this time I'm going to have, all the x's are going to be 0, so I'm going to have negative 2 to the 4th, 2 squared, and negative 4. So let's jump to a calculator. I know that negative 2 raised to the 4th power is going to be 16, and I notice that if I was doing a calculator, I need to have parentheses around that base, and so that's 16, and then I'm multiplying that. 2 squared is 4, 16 times 4 is 64, and then 64 times a negative 4 is going to be a negative answer, and I don't know off the top of my head what that is, so let's see what it is. Negative 256. Alright. It's not unusual to see these y-intercepts be very large or very small numbers, like this negative 256, because these exponents, if you have something raised to the 4th power, that's generally a pretty big value. So if it's bigger than 1. Let's look at, to find the x-intercepts, let's let the output of this function be 0. And they've factored this almost completely for us. The x minus 2 to the 4th power is completely factored. X plus 2, quantity squared, is completely factored, but x squared minus 4 can be factored as x plus 2 times x minus 2. Now notice that we can condense this, that we've got x minus 2 to the 4th and another x minus 2 to the 1st, and 4 plus 1 is 5. So we have 5 factors of this x minus 2. And we've got x plus 2, 2 factors here, plus another 1 factor there, for a total of 3 factors for x plus 2. So that's important that we get that right exponents there, because that's the multiplicity, and that's going to affect our answers in this table. So my first column in this table, I'm just calling it a column of zeros, which is also the x-intercepts of the graph. The middle column is the multiplicity. It's going to be the exponent on each factor. And the last one is telling you about how the graph appears, whether your function crosses through the x-axis at that 0 or whether it does a touch and turn. So we've got 2 minus 2 gives me 0, so I have x equals 2 as a 0. The 5 here is the multiplicity. Since 5 is an odd number, then as far as the graph is concerned, it's crossing. Then I have x equals negative 2 as a 0, and the multiplicity is 3, and that's odd, so this is also a cross. So this graph doesn't have any touch and turns. So there's the answers for number 4. Let's move on. To find the y-intercept, we let x equal 0. In factored form, if x is 0, this first factor here is give me a negative 12. And here, if these x's are 0, we've got 10. And negative 12 times a positive 10 is negative 120. So like I say, it's not uncommon to have, when students are first learning this, they find it surprising that you get x values of negative 120 or maybe negative 980 or positive 1,240. Sometimes these values are very big or very small in a negative sense. Now, we wanted to do our factoring. So we let the output of the function be 0, and x squared minus 4x minus 12 factors to x minus 6 times x plus 2, because negative 6 times a positive 2 is negative 12, and negative 6 plus a positive 2 is negative 4. And here, two numbers that give me 10 are positive 2 and positive 5, and 2 and 5 add up to 7. So now if I look at these, I have x plus 2 and another x plus 2. So you're going to write that as x plus 2 quantity squared, and this x plus 5. So now I'm just going to put ones here and here, and now I'm ready to list the x-intercepts, but only I'm going to put it in the form of a table, because they want not only the x-intercepts, which are called the zeros of the function, but they also want a description of how the graph intersects the x-axis. Does it cross the x-axis, or does it do a touch and turn at each individual zero? To help me determine that, I find the multiplicity at each zero, and then I'll be able to pick between cross or doing a touch and turn. Alright, so we have three x-intercepts, 3 zeros. We've got x equals 6. We've got negative 2 plus 2 gives you a 0. And negative 5 plus 5. At x minus 6, the multiplicity is 1 because that exponent there is 1. At x plus 2, the multiplicity is 2. That exponent there is 2. And then another 1 because that exponent is 1. When the multiplicity is odd, it's doing a cross. When the multiplicity is an even number, it does a touch and turn there. This is odd, so it's doing a cross. So there's our answer for number 5. Let's move on. Number 6, same direction, same idea. We're going to let x equal 0 to find the y-intercept. These first two terms are 0, and we have a y-intercept of 81. In standard form, it's always going to be a constant term. This is in what they call quadratic form because the degree of the middle term is half the degree of the first term. The degree of the first term is 4, and half of 4 is 2. So very likely we'll be able to factor this. We want two numbers that when multiplied give me a positive 81, but when added give me the negative 18. Well, that's easy to see that x squared minus 9 and x squared minus 9 do the trick. And oops, you might choose to write this as x squared minus 9 quantity squared. And now I need to factor x squared minus 9. So I can't forget about this 2 out here. X squared minus 9 factors to x plus 3 times x minus 3. When you have a power to a power, you multiply the exponents. So this x plus 3 is being raised to the second power, and this x minus 3 is being raised to the second power. So I'm going to write my table over here. I've got a table where the first column is my zeros. The second column is the multiplicity at each zero. And then to describe how it intersects the x-axis, does it do a cross or does it do a touch and turn? So x equals negative 3 is a 0 is an x-intercept of this function because negative 3 plus positive 3 gives me 0. Multiplicity is 2 because that exponent is 2, and because 2 is an even number, we know the graph is going to come to the x-axis and touch x equals 2 and then turn around. It doesn't cross through it, it does a touch and turn. At x equals positive 3, same thing. Multiplicity is 2, so it's doing a touch and turn. So there's my answers for number 6. Nope, I thought the directions might change. Alright, so let's do this one again to find the, well, not again, it's the same idea though. Plug in 0, and as soon as I see a factor of 0 here, this 0 cubed, who cares what follows? I can sit there and plug 0 into all of those x's, but when you have a factor of 0 in this list, as soon as it gets multiplied by 0, that whole thing is 0. So my y-intercept is y equals 0, and we know that the graph of this function passes through the origin. We need to factor this completely, so most of it is factored completely for us. The 7x cubed, the 3x minus 5, the 3x plus 7. When we look at these last three terms, all of these coefficients are even numbers, so I know I'm going to be able to factor out an even number, and they all have at least one factor of x. So then if I factor a 2x, well, 2 times 3 gets me 6, and x times x squared gets me x to the third. Since this is 2x squared, you've got 2x times 1x is 2x squared. 2x times a negative 10 is minus 20x. So now actually, let's take this 2 and 7. Let's take this 7 and this 2 and multiply those together and get 14. And x to the third times x to the first is x to the fourth. I can't do anything yet with 3x minus 5 or 3x plus 7. When I look at 3x squared plus x minus 10, 3 is an odd number, so I know it's going to start out 3x times x. And you can do the x method, but what you'll find out is that if we have this be a plus 2 here and a minus 5, it's going to work because 3x times x is 3x squared. 3x times 2 is 6x, but then you take away 5x, it gives you 1x, and negative 5 times the positive 2 is negative 10. If I've done that too fast, just come over to the side and do the x method. The 3x minus 5 and the 3x minus 5 are going to combine. So I've got 14x to the fourth. I've got 3x minus 5 with another 3x minus 5. That means that's squared. I've got 3x plus 7, and that's just to the first power. And I've got x plus 2, and that's just to the first power. So I can't tell if somebody's knocking, or hang on a second. Alright, I'm back. I think what I heard was just Mrs. Miner leaving. I'm not sure. Alright, so let's put this in the form of a table. So I'm going to you've already got, I'll give myself some room for this table. I'm going to get rid of this. I'll keep this answer of my y-intercept for you. And let's get rid of some of this to give us some more room, or at least give me some more room. So this first factor provides us an x-intercept of 0, and 3x minus 5, if you add 5, if set this equal to 0, add 5 and divide by 3, and here, if you subtract 7 and divide by 3, and here a negative 2. So let's do this in the form of a table. These zeros that are also called x-intercepts, we've got 4 of them. We've got x equals 0, 5 over 3. And I'm just going to leave it as an improper fraction. And negative 7 over 3. And let's squeeze in x equals negative 2 down here. Our multiplicity for each of these zeros are the exponents up here. So this x equals 0, this 4, that's the multiplicity. This 2, that's the multiplicity. This 1 and this 1, these are those multiplicities. So I know when we go to graph this, that as the line approaches x equals 0, it's either going to cross that x-axis or it's going to do a touch and turn. If the multiplicity is even, it does a touch and turn. Here the multiplicity is an even number, so it's doing a touch and turn. Here the multiplicity is odd, so the graph is crossing the x-axis at x equals negative 7/3, and also at negative 2 it's crossing. So that's what it wanted for those answers. So let's come here. Okay, so now we actually have a graph and we're going the other way. So we want to write a polynomial function. And It's here at -4, it's crossing, and in factored form, this x equals -4 is written as x plus 4, and since it's crossing, this exponent's going to be an odd number, and I want the lowest degree, so I'm just going to pick 1. Over here at x equals 2, that's a 0. In factored form, we write it as x minus 2. Since it's doing a touch and turn, this is going to be an even number, so I'm just going to pick 2. Now, I have to figure out what this leading coefficient, what this number is going to be, and I can see that it's telling me down here at the bottom that when I read this graph that it has a y-intercept of 16. So in other words, when you plug in 0, when x is equal to 0, when I have 0 plus 4 and 0 minus 2 squared times this number at whatever a is, I need a to be such that when you multiply all these together, you get this 16. So -2 squared is 4, and 4 times 4 is 16. And this solution divided by 16, hey, a has to be 1. So we kind of get the answer I think that you would want anyway, is that if a is 1, we just have x plus 4 times x minus 2 quantity squared. And so there's our answer for number 8. Let's come along here and take a look at number 10. I see that I have two x-intercepts, two zeros of this function. At -3 in factored form, we write this as x plus 3. Since this is doing a touch and turn, it's coming down, the graph is coming down and touching the x-axis at -3, and it's turning and going back up. It's not going all the way through it. So I know that this exponent is going to be an even number, and I know because it's a polynomial function, I can't have negative exponents, so I'm just going to pick 2, and because it said lowest degree. And here at the origin, if you want to, you can put -0, but that's just x. All right, I'm back. And you're going to like it when the y-intercept is 0, when your graph goes through the origin, because then that gives us a freedom to pick any a that we want. So I'm just going to pick 1 for a. I'm just going to have x plus 3 squared, and I'm going to write x minus 0 as x. So I'm just going to write x squared, but only I'm going to put it in the front here, because we can write the order of multiplication any order we want. So hey, that's my final answer for 9. Alright, so let's write this polynomial function. We have an x-intercept at -3 in factored form, that's x plus 3. Since it's doing a touch and turn, I'm going to make that a squared. Over here at 1, it's crossing through there, and since x equals 1 in factored form, I have a -1. And over here, since that's 4, I have a -4. But with the cross, I'm just going to pick an odd number 1, and with the touch and turn, I'm going to pick squared. Now I have to have an a here, because I have to pick a in such a way that when you let x be 0, that all of this multiplies together to get us -144. So I don't know what a is yet, but when you have 0 plus 3, you'll have 3 squared. 0 minus 1 is going to be a -1. 0 minus 4 is a -4, but that's going to be squared. And this, we need a so that when you multiply all this together, you get -144. Alright. So 3 squared is 9. -2 squared is 16. And 9 times 16, was that 256 before? 9 times 16. No, 144. And it should be negative. So we're getting the a equals 1. And you guys like it when a equals 1, because now you might have guessed 1 and you'll end up getting the problem right, correct? So there's my final answer. If a is equal to 1, I don't have to put the 1 there. Multiplied by 1 is, and I'm going to leave it in factored form. Alright, so let's take a look here at this problem. We've got polynomial. Since it's going through the origin, the y-intercept is 0, I can pick any a that I want, so I'm just going to pick 1. In factored form, this negative 4 is written as x plus 4, and since it's crossing the x-axis, I'm going to have the multiplicity be 1. Here at the origin, for now I'm going to write it as x minus 0. It's doing a touch and turn, so it's a squared. Over here at x equals 3, in factored form, that's x minus 3, and since it's crossing, that's a 1. So we're fortunate that we can pick any number that we want. If you want to pick your favorite number, maybe 10 is your favorite number, or maybe your jersey number is 24 or whatever. We've got x squared times x plus 1 times x minus 3. And there it is. There's my answer for this number 11. Alright, for the very last one, we're back to a description. We don't have a graph, but we know we can picture what the graph would look like. In factored form, now see, it's listed twice, so really what I should have done is said that it has zeros at x equals negative 2 with a multiplicity of 2, but instead I just listed it twice. So in factored form, that's x plus 2, and because that's listed twice, it wants us to have a multiplicity of 2. Now, the 4/3, that's going to be 3x minus 4, because if you work backwards, if you have x is equal to 4/3, multiply both sides by 3, and then subtract 4 because you're trying to get 0, and then 3x, because that's why it's called a 0, the function. This 3x minus 4 is one of the factors. And then x equals positive 2 is just written as x is negative 2. Doesn't say a thing about the y-intercept, so we can have any y-intercept that we want, which means we can have any number here that we want. And we're just going to have the multiplicities be 1 here, because just like the negative 2 that it listed it more than once, if we wanted a bigger multiplicity, we're going to assume that they would have done the same thing with these other zeros if they'd wanted something different than 1. So hey, sorry I had to make this in one video, and sorry that it took so long, but that's the way I had to do it tonight. Talk to you later. Bye.